For decades, we've had this dream of building a new home on Mars. And we've come up with some incredible tech to help us breathe, drink, and survive on the red planet. But there's one terrifying force on Mars that all our science has no answer for. Not yet. A force that's already claimed one of our own.
So what is it? Well, in this explainer, we're going to break down the incredible challenges of surviving on Mars, look at our most ingenious solutions, and then come face to face with the one massive, planet-sized problem that we still can't fix. But first, let's back up. Why are we so obsessed with a seemingly barren planet that's on average 225 million kilometers away? The simple, and frankly, slightly alarming answer is survival. Humanity needs a backup plan. I mean, when you look at the list of potential threats to our home, it's long and it's growing. We're talking about everything from dwindling resources and a rapidly changing climate to the ever-present dangers of pandemics, war, or a catastrophic asteroid impact. The same kind of thing that wiped out the dinosaurs. To really ensure humanity's long-term future, we need a second home.
And of all the places in our solar system, Mars is by far our best candidate. Now, you might think of it as this totally alien world, but honestly, it's a lot more like Earth's distant cousin than you'd probably expect.
It's actually kind of wild how familiar Mars looks on paper. A Martian day, which they call a sol, is only about 36 minutes longer than our own. The planet has seasons, just like we do. It has icy poles and a familiar landscape of mountains and valleys. It's even home to Olympus Mons, the largest volcano in the entire solar system. These similarities are exactly why we've picked Mars as our future colony.
Of course, it's not perfect, not by a long shot. Living on Mars presents some huge challenges, but for almost every single problem, human ingenuity has come up with a brilliant solution. Let's start with the most basic one of all.
The Martian atmosphere is over 99% carbon dioxide. There's barely any oxygen. You literally couldn't survive for a single second without a helmet. So how do we get the air we need to breathe?
Turns out we literally make it from the Martian air itself. This incredible device called MOXIE basically acts like a mechanical tree. It sucks in that CO2-rich atmosphere, heats it up, and then uses electricity to split the molecules apart, creating pure, breathable oxygen. It is an absolute game changer.
Okay, so we've got air. What about water? Well, we know there are huge reserves of water on Mars, but it's not exactly flowing in rivers. It's all locked away as ice, deep beneath that red soil.
The solution here is a real feat of engineering. We're developing these advanced drilling rigs that can bore down into the ground, melt the ice where it is, and then just pump the liquid water up to the surface. And this water isn't just for drinking. It's absolutely crucial for growing food, and we can even split it to create more oxygen.
So we can breathe and we can drink. But we still have to deal with the harsh environment itself. It's unbelievably cold, often dropping below minus 60 degrees Celsius. And because it doesn't have a protective magnetic field like Earth, the surface is constantly getting blasted with deadly solar radiation. And this is where our creativity really goes into overdrive. We've designed everything from inflatable habitats to entire underground bases. We can even build bunkers out of the Martian soil itself, which happens to be a great radiation shield, or just move into natural caves that are already there. It seems like for every problem, we've got a solution, except for one.
We've just seen how we can pretty much engineer our way out of any challenge Mars throws at us. But now we get to the one thing we can't control, the one thing we can't perfectly predict, and the one thing we absolutely cannot stop.
I'm talking about Martian dust storms, and these are nothing like the storms we have here on Earth. On Mars, these things can grow so massive, they swallow the entire planet, plunging the surface into a thick, dark haze that can last for months.
When you see pictures of Mars, it looks so calm, so still, but that silent red world is hiding a very violent secret. So let's break down what makes these superstorms so uniquely dangerous. Get this, a planet-killer storm happens about every 3 Earth years. They're usually kicked off by huge temperature swings at the poles that cause frozen carbon dioxide, dry ice, to turn straight into gas. This creates these enormous winds, and because Mars has such low gravity, once all that fine red dust gets kicked into the air, it just hangs there for months, completely blocking out the sun. Now you're probably thinking the main danger is the wind, right?
I mean, 160 kilometers per hour sounds devastating. On Earth, it would be. But here's the crazy part. The Martian atmosphere is so incredibly thin, like 1% of Earth's, that even a hurricane-force wind would feel more like a gentle breeze. It wouldn't even be strong enough to knock an astronaut over. So here it is, the crucial point. The wind won't kill us. The darkness will. Think about all of our amazing solutions, making oxygen, pumping water, heating our homes. All of them depend on one single thing, solar power. And when a planet-wide storm hits, that power source is completely cut off. And the scary thing is, we don't have to imagine what this is like. We have a tragic, real-world example of just how deadly the Martian darkness can be. And it's the story of NASA's beloved Opportunity rover. Opportunity landed way back in 2004 for what was supposed to be a 90-day mission. 90 days. But this little rover was so tough, so successful that it just kept going for 15 years. An absolutely incredible journey of discovery. But in 2018, it ran into one of those planet-encircling dust storms. The sky went dark, and the rover, which ran completely on solar power, was forced into a deep sleep to try and conserve energy. The storm was so intense that it blocked out 96% of all direct sunlight from reaching the rover's solar panels. For a machine that lives off the sun, this was a death sentence. For months, NASA engineers kept trying to get in touch, sending over 1,000 commands just hoping for a reply, but all they got back was silence. And then one last faint message was received. It wasn't a reply, it was the rover's own automated systems reporting its final status. My battery is low and it's getting dark. That was the last thing we ever heard from Opportunity, and it serves as a chilling warning for our own ambitions. Before we send people to Mars, we have to solve this one final mystery. How will we survive when the sun disappears and the long Martian darkness falls?